Hi guys, welcome to my channel. So I have been off for a little while, but I'm back and I promise to dedicatedly create videos and content on data engineering. So today what we will do is we'll take a very real life scenario which I faced just recently, and just I will just explain that it doesn't need a problem to be very difficult until you think it is. So normally what happens is that when you get requirements from a business stakeholder, they frame it in a way that it sounds that, oh my god, it's so difficult to solve it, but actually when you break it down into parts and then try to solve it, it becomes very easy. So that's what I'm going to show you today. So those who are new to my channel, welcome for the first time, and I'm very grateful that you followed me. So what I do is I take some SQL problems or any problem statement, I write that in SQL and then I convert into Pyspark. So I will just show you that when you first solve it in SQL and how easy it becomes to convert it into Pyspark, because and if you're good in SQL, then Pyspark will really easy for you. So that's a very important and very useful hack that you can use in interviews, because in interviews also what they do is they give you a big problem statement which seems very difficult or hard to solve at first, but if you break it down it becomes very easy. So let's get straight to the point. So this is my input. Okay, so you see that there are 1 2 3 4 columns, right? And the case identifier column is a GUID, okay, global unique identifier. Then we have the main case ID column, then we have the main case identifier column, and then we have the linked case code. Okay, so what happens is basically I will just give a brief of this scenario, how it arrived. Basically we have a UI, okay, and from there, so what happens in a UI is that you click on a link and it takes you to some other page. From there you can fetch the fields. So when you do that through any tool or ADF, but you just bring in the columns, right? Then you have to find the communication or the connection between the different objects and then link the columns with it. So in SQL, how do we do that? We use joins. So the scenario here is that wherever in this data set, okay, the one I'm selecting, wherever in this data set the case identifier and the main case identifier will be equal, what will happen is I want to create a new column called case ID, and the case ID value will reflect the main case ID, okay, and sorry, not the main case ID, the linked case code for that particular record. Okay, sounded complicated, right? So that's how we get it from business stakeholders, but let me break it down to you. So basically, see, one more thing is there. So once when you see that the scenario is that case identifier is equal to main case identifier, you will think that it is for a particular record, right? And in this case, because someone commented on my LinkedIn post that in this case your sample data set doesn't match your explanation, so that's not the case. Okay, so it's for the entire data set. For example, here are 2 records over here. I can put in more, but just to save time I am putting only 2. So wherever you see that the case identifier is equal to main case identifier, so in this case these are 2 separate records. Okay, this is record 1, this is record 2. Okay, let me just write it like that. So this is record 1, okay, and this is record 2. So the case identifier in record 1 is equal to the main case identifier in record 2. That's when there is a match between these two, the linked case code will become the case ID for that record. Okay, so let's see for the first record. The case identifier is a match with this particular record, right? The second record. So the linked case code, that is LC123, will become the case ID for the first record. Okay, similarly, if I go to the second record, I will see that the case identifier is this 1 2 3 ABC, 4 zeros and 2. It will try to find the match for the main case identifier in the entire data set, and it finds the match in the first record. Okay, so as soon as there is a match between these two, it brings the linked case code of this record, okay, because that this is the record it has found the match in. So it brings the value of this LC98765 from the linked case code column and writes it in the case ID. Okay, I hope it's clear, right? But when you suddenly see the statement, it becomes difficult. Now how do we solve this? Now we know that it has to happen on the entire data set, right? So we cannot just use anything like case when, case identifier equal to main case identifier. That won't work because case when works on one single record, right? But we have to traverse through the entire data set to solve this. So the first thing that comes to my mind is that what if we have a replica of this data set where we can match the following. So basically if we have something like this, okay, let's say we have something like this, that this is the data set, and then we have another thing like this, okay, so then we can match the following, right? Like we used to play in childhood, match the following. So we can do something like this. So first thing that comes in my mind is join. Okay, so this is called self join, where you have only one table, right, and you self join with it by itself to solve your problem. Okay, so let's get to the point for the SQL code. So what I'm doing is I'm just selecting all my required columns that I need. Okay, so now you also see one more thing, that so first is the table 1. Okay, so first data set, okay, before I am joining it. So T1 is that, and then I'm joining with my same table, but I'm aliasing it as T2. Okay, what is the reason for T2? Because I want to portray my case ID column also, because that is a requirement that I want to add a new column case ID. But this case ID is the same value as this, right? Linked case code. So how do I take it? So when I join it with that same table the second time, that second table ka linked case code becomes my case ID. Okay, so it's a very simple code. And then when we join, it's a very it's a very how do you call it, significant syntax, like it's a very mandatory syntax. So we are joining on case identifier and main case identifier. Okay, so basically if this is my first table, this is my second table, what I will do is I will just check that where the case identifier in the first table has a match with the main case identifier of the second table. So okay, so I see one thing. So this I'm selecting, right? This is my first table, this is my second table. So case identifier 123 ABC 401 in my first table has a match with the main case identifier in the second table over here. So since it has found a match in this one, you see my cursor, the linked case code of the second table becomes my case ID for the first record. So basically I selected this record. Okay, I tried to find that this record has a match with which record in the second table based on the condition that case identifier will be equal to the main case identifier. As soon as it found it, what it did, it brought this linked case code ki okay, this is going to be my case ID for my final output. Okay, so this is how it works in SQL. Now this is my SQL code. Okay, it's a very simple code of self join. Now what we are going to do is we are going to convert this into Pyspark. Okay, so if you have any doubts for SQL, you can let me know in the comments. I will definitely help you out. So let's move to Pyspark now. So for Pyspark, I'm using Google Colabs. It's a free what do you call it, IDE on the internet, so I don't have to pay anything. Okay, so I'm not going to explain all of this because this all is explained, like how are we writing the syntax for Spark, why are we importing Spark session, what is a Spark session in the first video. So if you're a beginner and new to Pyspark, I would recommend to go to my first 2 videos where I have explained this in details. So in this video, what I'm going to do is I'm just directly going to explain that how to convert a SQL code into a Pyspark code. Okay, so this is the basic syntax that you need to write in every Pyspark code, right? And then you need to write the data also. Why? Because obviously we want our code to work on an input data. So what we are doing, we are defining the data in the form of a list, that these are the things. Now this is without headers, right? So we have to give the header also. So we are defining that columns equal to this, and under this a tabular format will be formed. How? So when we write df equal to spark dot create data frame, right? What happens is this creates a tabular format in the form of table. I mean, yeah, tabular format and table is same. So it creates a table with the columns and the data under it. So you can refer to it as a table. So there's a thing in NumPy and pandas also, that what is the difference between data frame and series. So data frame is basically the table, series is the columns. Okay, now so we have created our data frame. Okay, so basically the output for this will be, your data frame will be this. Please ignore this one, this I had just written to explain. So your output of the data frame is going to be this. Okay, without this 1 2, this also I had just written to explain. So this will be a tabular format where you work on your input data. Okay, now I'm creating a new data frame. So I'm just joining, like I did the join, right? So I'm just converting that code. So how am I converting that code? So I have a so see, it's a self join, so it's going to be the same data frame joined with the same data frame, like we had in the table. Same table joined with the same table, but only the alias is different. So same thing we are going to do in Pyspark also. So df.alias, so this data frame I had created, I'm aliasing that as t1, and then I'm joining with the same data frame df, but I'm aliasing as t2. Okay, so basically now t1 joins with t2, and then I am giving the conditions that t1 case identifier and t2 main case identifier, and vice versa, t1 main case identifier and t2 main case identifier. So this is my condition of my join. Okay, so when I'm joining these two data frames, this condition should be satisfied. And how is the joining done? I'm doing a left join. Okay, so and once this is joined, what am I doing? I'm just selecting my required columns. So same thing I did, I joined the two tables. Once the tables were joined, I'm selecting the columns that I require, and then I'm showing the result. So dot show in two brackets, two parentheses. So this is what my output is. So you see how easily we just converted a SQL code into a Pyspark code, right? So this is what self join is about. So two key things that we learn from this video is, one is, no matter how difficult a business statement looks like, if you break it down, in terms of the data, when you check the data, analyze it, and you see that you have this matches between these two columns, right? So it becomes very easy. And then number two is, once you write the SQL code, it's very easy to convert into a Pyspark code. Instead, if you try directly working on Pyspark, because it might feel overwhelming that Pyspark has this many lines of code, right? So this is all about today. See you in the next video, where we talk about CTEs and how we solve CTEs with Pyspark as well. So thank you for watching my video. Please do like and subscribe. Thank you so much.